Welcome to Homework Lib.
Hi, so over here we want to select which one is going to represent the most stable configuration for the 2,3-dimethylbutane. So in this case, what we are looking for is the configuration that is going to be staggered and has the least amount of gauge interactions. Recall that the gauge interactions are going to be the ones in between groups contain carbon atoms on these positions. So in this case, we are only going to consider the ones that are going to be staggered, since those are the ones that are going to be more stable compared to the eclipse conformations that we see over here. So we can discard those already. Let me put this one in red. And now we just need to count the number of gauge interactions that we're going to have on each of them. So over here, what we're going to get is going to be one gauge interaction in between these two CH3s. Next up on this configuration, next up over here, we're going to have 1 and 2 gauge interactions. And in this case, we would have 1, 2, and 3. So in this case, you would think probably that this one would be the most stable one. But what happens here is that this is not going to be the configuration that we're looking for. Why is that? We're looking for 2,3-dimethylbutane. And 2,3-dimethylbutane is going to have the following structure. Essentially, the carbon atoms that we're looking at in our Newman projection are going to be these two carbon atoms over here. So each of the carbon atoms on the Newman projection should have two CH3 groups, as you can see from this drawing. If we count the number of substituents over here, this is not going to be 2,3-dimethylbutane. This is going to be simply 2-methylbutane. And as such, the configuration that would be the most stable out of all of them is the one over here. And with that, it would be all. Thank you very much and have a good one.